Hi student, today we will be solving the IB Math AA HL May 2025 paper 1 time zone 3 question number 10. You will be getting the solutions for the first 9 questions from this paper and the solutions to the other questions from the other past papers in form of playlists on my channel NS Online Math Tutoring Classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I am Nilanjana Sanyal. I am an online IB Math AA level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve this question number 10. The maximum mark is 16. Consider the sequence of the numbers un with the nth term given by un. The first 3 terms are u1 equal to k minus 5, u2 equal to 3 minus 2k and u3 equal to 5k plus 3, where k is a real number. So part A's question is, consider the case where this sequence un of un numbers or terms is arithmetic. Subpart A is having 2 further subparts. The first subpart I is saying find the value of k. We are having k in each of these 3 terms and the sequence is arithmetic. So there will be a common difference. Okay. So u2 minus u1 should be equal to u3 minus u2. That is the common difference D. Okay. So what is u2? u2 is 3 minus 2k minus u1 is k minus 5. This should be equal to 5k. u3 is 5k plus 3 minus u2 is 3 minus 2k. Okay, 3 minus 2k. So now I open the brackets. It is 3 minus 2k minus k plus 5 is equal to 5k plus 3 minus 3 plus 2k. Okay. So this is equal to 3 minus 3k plus 5. Okay, let me write this. 3 plus 5 is 8. So 8 minus 3k is equal to, and 5k plus 2k is 7k and 3 minus 3 is equal to 0. These two will be cancelling. So we are having 10k, we are adding 3k to both the sides. It is 10k equal to 8, or k is equal to 8 over 10 or 4 over 5. Okay. So we have answered the first subpart. Subpart I is saying hence or otherwise find u3. So we are given the expression of u3. We will be just plugging in the value of k in this expression to get the value of u3. Of course, we will be using the hence part. So it is I u3 equal to 5k plus 3, which is 5 times 4 over 5 plus 3, and these two will be cancelling, so it is just 4 plus 3. So therefore u3 is equal to 7. Okay. Subpart B, consider the case where k is equal to 12. This is also having 2 subparts. Subpart I is saying show that the first 3 terms of the sequence form a geometric sequence. Okay. So let us start my answer for the subpart B and I over here. Since it should be a geometric sequence, it should be having a common ratio. Let us see if it is having a common ratio. And the case value has been given to be equal to 12. So what is u2 over u1? This is equal to 3 minus 2k. over k minus 5, which is 3 minus 1, k is 12, 2 times 12 is 24 over 12 minus 5. Okay, so this is equal to 24 minus 3 is 21. So it is negative 21 over 7, which is equal to, therefore, u2 over u1 is equal to negative 3. Let us find what is the ratio between u3 and u2. So u3 over u2 is equal to 5k. Don't write u2 over u1 equal to u3 over u2. You do not know whether u2 over u1 is equal to u3 over u2. You have to establish that fact that it is equal. They are equal. Okay. So 5k plus 3 over 3 minus 2k equal to 5 times 12 is 60. So 60 plus 3 and 3 minus 24. So this is equal to 63 over negative 21. Therefore, u3 over u2 is equal to negative 3. Since u2 over u1 is equal to u3 over u2 is equal to negative 3, therefore, the sequence is a geometric sequence. Okay, fine. So this is shown. I, given that the sequence of un terms is geometric, state a reason why the sum of an infinite number of terms of this sequence does not exist. Okay, so this is I. Since the common ratio is equal to negative 3, or common ratio R is equal to negative 3, which is less than negative 1. Therefore, because in order to have the sum of an infinite number of terms from a geometric series, we should be having the common ratio lying between negative 1 and positive 1. But over here we are seeing that the ratio is negative 3, so which is less than negative 1, therefore the infinite series will not be existing. Okay. Therefore, the sum of an infinite number of terms of this sequence does not exist. Okay. So part C, the sequence of the union terms is geometric. For a second value of k, that means one of the values of k is 12, and there is another value of k for which this sequence is a geometric sequence. Subpart I, this is having 3 subparts. Subpart I is saying show that k square minus 10k minus 24 is equal to 0. Okay, so since this is subpart Ci, since it is a geometric sequence, how to come to this? We do not know how to come to this equation. Only thing that we know that this is a geometric sequence, so there should be a common ratio. So u2 over u1 should be equal to u3 over u2. That is what we know. So let us start from there. Okay. So since it is a geometric sequence, U2 over U1 should be equal to U3 over U2. Okay. And what is U2 over U1 equal to? This is 3 minus 2k over k minus 5. U2 over U1 equal to 3 minus 2k over k minus 5. Okay. Implies 3 minus 2k over k minus 5. This should be equal to what is U3 over U2? U3 over U2, this is 5k plus 3 over 3 minus 2k. Okay. 5k plus 3 over 3 minus 2k. And now we will be multiplying, we will be cross multiplying, or I can say we are multiplying both sides first with 3 minus 2k. Okay. So this is 3 minus 2k whole square over k minus 5. I am multiplying both sides with 3 minus 2k instead of cross multiplying. You can do the cross multiplication directly as well. And next, I am multiplying both sides by k minus 5. So it is 3 minus 2k whole square is equal to 5k plus 3 and k minus 5. And now we have to expand, and it will obviously be a quadratic equation. This is a minus b whole square. I'll be using the formula in case you are confused, you are not sure of the a minus b whole square formula. Just multiply them directly, 3 minus 2k times 3 minus 2k. Multiply term by term. Okay. Don't write something which is wrong. A minus b whole square is definitely not equal to a square minus b square or a square plus b square. Okay. It is a square minus 2ab plus b square. So a square, a is 3, so it is 9, and b is minus 2k. If I consider a plus b, okay, I am considering a minus b, so I am considering only 2k. So b is 2k, so b square is 4k square, and minus 2ab is 2 times 3 is 6 times 2 is 12. 12k is equal to 5k square minus 25k plus 3k minus 15. Okay. So 9 plus 4k square minus 12k is equal to 5k square. This is 5k square, and minus 25k plus 3k is minus 22k minus 15. So since this is a quadratic equation, so I'll be taking all the terms to one side and the other side will be equal to 0. And the equation is also given in that form. The right side of the equal to sign is having a 0. Okay, so, and it is k square given. See, k square minus 10k. So if I subtract 4k square from both the sides, I'll be getting 5k square minus 4k square. So I will be subtracting these three terms from both the sides. Okay. So what happens? 5k square minus 4k square will be giving us k square. And minus 22k, and I'm subtracting. So the sign will be changing. Plus 12k will be equal to minus 10k. And minus 15 and minus 9 will be minus 24 equal to 0. K square minus 10k minus 24 equal to 0. K square minus 10k minus 24 equal to 0. Okay. Shown. I. Find the first three terms of the sequence of un terms for this second value of k. So we have to get the two values. One of them will definitely be equal to 12. Let us factorize this. Okay, so 24 minus 24, it can be 12 and 2, negative 12 and positive 2. So it is k square plus 2k minus 12k minus 24 equal to 0. Okay, this one is II. Yes, this one is II. So equal to k and k plus 2 and minus 12, k plus 2 equal to 0. So this is k minus 12 and k plus 2 equal to 0. So therefore, k is equal to 12 or k is equal to negative 2. So this is this other value of k, because we have previously taken k value as 12. So they are saying find the first three terms of un for this second value of k, which is equal to negative 2. Okay, what is the first terms expression? u1 k minus 5. So therefore, u1 is equal to k minus 5 is equal to minus 2 minus 5 is equal to, therefore u1 is equal to negative 7. Okay, or I can write the three terms together also. u2, this one is 3 minus 2k. Let me show you again. u2 equal to 3 minus 2k. u2 is equal to 3 minus 2k is equal to 3 minus 2 minus 2. Therefore, u2 is equal to, this is 4. So 3 plus 4 is 7. And u3 is equal to, it is 5k plus 3, but anyway, I'm showing it over here. u3 equal to 5k plus 3. 5k plus 3 equal to 5 times negative 2 plus 3. So, therefore, u3 equal to 5 times negative 2 is negative 10 plus 3 is negative 7. Okay. So, therefore, the first three terms are 7, sorry, negative 7, and then positive 7, and then again negative 7. Okay. Finally, I hence write down the value of S2m, that means the sum of the first 2m terms, for this second value of k, first 2m terms. Okay. I u1 is equal to negative 7, and what is the common ratio? Common ratio, just by looking at the numbers, we can see that the common ratio is negative 1. Okay. So, S2m should be equal to minus 7 u1 minus 7 times 1 minus r to the power of 2m over 1 minus r. Okay. So, this is equal to minus 7, and we do not know the value of m. Doesn't matter. Doesn't matter really. Because 2m is an even number. Whatever may be the value of m can be equal to, m can be some even number, then 2m is an even number. Even if m is an odd number, 2m will be an even number. And if m is equal to 0, 2 times 0 is 0. Whatever may be the case, minus 1 time raised to the power of some even number will be equal to 1. And if it is minus 1 raised to the power of 0, even then it will be equal to 1. Clear? So, 1 minus 1 and divided by 2. Minus of minus 1 is 1, so 1 plus 1 is 2. Since minus 1 raised to the power of 2m is equal to 1. Okay? So, therefore, is 2m is equal to 0. Clear? So, we have solved this question completely. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please subscribe to my YouTube channel. Your liking, sharing and subscribing will be really helping me a lot. We meet again very soon in the next session. We solve question 11 of the same paper. Till then, bye.